Today we're going to begin our study in dynamics. Specifically, we're going to be looking at forces and Newton's laws. A force in layman's terms is a push or a pull. Now, this relationship between forces and motion was first discovered by Newton. He was around in about 17th century. And we call our mechanics Newtonian mechanics because we're looking at objects that don't move close to the speed of light and that are fairly large in scale when you look at them with respect to the atom. Now, Newton came up with 3 laws while he was on his father's estate during the bubonic plague. Newton's first law basically is that an object at rest stays at rest, and that an object in motion stays in motion unless there's an external force acting on it. Now, this is actually a special case of Newton's second law. Newton's second law says that our acceleration of an object is proportional to the force, the net force applied to an object, and is inversely proportional to the mass of the object. So if we looked at this for the case where the acceleration is equal to 0, what we would end up with is we would end up with either an object that is stationary, which would be the case of where it basically is not moving at all, it's staying at rest, or the object is moving with a constant velocity. That means that it's staying in motion, same motion as before. So Newton's first law is a special case of Newton's second law. Now, Newton's third law is often called action-reaction. Basically, if we have 2 objects, object A and object B, and they are interacting with each other, the force that is applied on object B by object A is equal in magnitude and opposite in direction to the force that is applied on object A by object B. Basically, for every force that is applied, there is an equal and opposite force that's respond. These 2 forces are what's known as a third law pair. They are acting in response to each other. Now, when we talk about forces and we talk about Newton's laws, we cannot do it without talking about a free body diagram. A free body diagram is essentially a picture of the forces that are acting on an object. This is only the forces. This is only the forces applied. There's no accelerations, there's no anything else. Now, typically when I draw a free body diagram, I draw either a box or a really big dot that I'm applying my forces to. And you're going to show your forces as being applied in the correct position. So you're going to have the weight, and you're going to want these to be physically touching the object. You're going to have your weight coming down, so that's your force due to gravity. You don't have to label it with numbers, but it does need to have a label. Now, if it's on a surface, you may also have a normal force. That normal force is acting from the surface of the object. So that's our force normal. You may have a frictional force. That frictional force opposes the direction of motion, and it's typically shown as being applied at the base of an object. You may have a tension due to a rope or a string. So all of these are roughly drawn to scale. They are vectors, but you only draw the forces. There's no distance, no accelerations, none of that is drawn in this at all. So take some time. Remember, anytime you're working with forces, you need to draw a free body diagram. It helps you visualize what is happening in the problem. So next time we're going to look at all of these types of forces and get some more information as to how they work together.